Okay, we're going to take a look at rational versus irrational numbers. So again, take two lines and go ahead and title your tab and tear it out. Alright, so rational versus irrational. So you're going to leave a little space in the middle and we're going to define what rational numbers are. So rational numbers can be written as a fraction. Rational numbers can be a decimal as long as the numbers are repeating after the decimal. So let's look at irrational. Irrational numbers cannot be written as a fraction. This is a listening check. Underline the word cannot. And irrational numbers has endless non-repeating numbers after the decimal. Non-repeating numbers after the decimal. In other words, all the numbers after the decimal are different. Okay, so let's take a look at some examples. So all our examples are going to go in the middle. So example number 1, the number 2, is that rational or irrational? So the first thing you think is, can I write it as a fraction? Yes, I can. If I just put a 1 underneath it, it becomes a fraction. Or is it a repeating after a decimal? Yes, it's 2.000000000. So yes, it's rational. So we're going to put it on the left-hand side. Let's take a look at another example. Example 2, pi. Now, if you don't know what pi is, just take your calculator, hit second, and then that up arrow, it'll give you pi. Pi is 3.141592, blah, 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 blah. It goes on forever. So are those numbers repeating after a decimal? No. Therefore, that means that pi is irrational. This is a listening check. Color in example 2. Color in example 2. Okay, let's take a look at another example. -3. So a negative integer. Is that rational or irrational? Can I write it as a fraction? Yes, I can put a 1 underneath it, right? So I can say -3/1, which makes it a rational number. I can write it as a fraction. Example 4, 1/2. Can I write it as a fraction? It's already a fraction. Therefore, what is it? Rational. So draw an arrow to the left-hand side. Example number 5, square root of 2. Alright, so anything that isn't a perfect square will be an irrational number. So for example, if you go ahead and put it in the calculator, you'll see that it won't give you an integer. It'll give you a non-repeating decimal. See how all the numbers are different? That means it's irrational because it's non-repeating after the decimal. So square root of 2 goes on the right-hand side as irrational. Example 6, radical 3/5. So again, we know radical 3 is not a perfect square, so that's an irrational number. Divide that by a rational number, you still get an irrational number. So let's go over a couple of things, because sometimes we have a calculator. Perfect squares are 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and so forth. So if it's not one of those numbers, it's not a perfect square. It'll give you an irrational number. Therefore, I already know it's irrational without a calculator, but I'm going to go ahead and show you with a calculator. So sometimes we'll give you a calculator, sometimes it won't. So you do square root of 3, then get out of it, then divide it by 5. And you can see those numbers are not repeating. Be very careful what you type in the calculator, because you could type it in wrong. So for example, you see if I didn't get out, the square root goes over the whole thing, which is not what the question is asking. Square root is only supposed to be root of 3. Now let me go ahead and clarify, because I just realized this is a fraction. We're going to change our definition to a fraction of integers. So you can see square root of 3 is not going to give you an integer. So it isn't considered that it can be written as a fraction, because the square root of 3 is not an integer. Alright, example 7. So let's look at some combinations, because they're going to put them together. If I take pi and add another pi, so if I add 2 irrational numbers together, what's going to happen? I'm going to get an irrational number. It's going to be 6 point something something. And I'll just show you in the calculator real quick. And you can see they're not repeating. This is a listening check. Ignore that thing in red that says sum, adding. Alright, so let's take a look at multiplication. If you had 2 times an irrational number, it is still going to be irrational, because 2 times that was just like adding them together twice. Alright, example 9. What if I multiply 2 fractions together? Well, so if I have 2 rational numbers and I'm multiplying them together, the answer is going to be rational, because a fraction times a fraction is just another fraction. So even without a calculator, you can do these questions. So I'll keep showing you in the calculator so you can see. Make sure you put them in parentheses so that it knows that it goes together. Okay, then you see it's a repeating decimal. That's why it's rational. Now you can make that repeating decimal into a fraction. You can check on a calculator to see if it's a fraction by hitting math, enter, enter. So you can check if a decimal is going to make a fraction. Math, enter, enter. So it gives me the fraction 4/9. Put a box around what we're writing right now, math, enter, enter, to get a fraction, and then color in that box. All right, example 10. What if I add two fractions together? Well, if I add two fractions together, I'm going to get another fraction. So when you add two rational numbers together, you'll get another rational number. And again, I'll just show you in the calculator. Please make sure you put your fractions in parentheses before you multiply or divide or add. Get 1.1. So let me add one more definition under rational numbers. Rational numbers, also the decimal ends. So if the decimal ends, it's rational. So in this case, it's a rational number because the decimal ends. And again, math, enter, enter will make it into a fraction, and you can see that's a rational number. All right, example 11. What happens when you multiply two irrational numbers together? So it's radical 3 times radical 2. Well, we've been practicing this, right? Radical 3 times radical 2 is the same as you put them under the same square root, so 2/3. 2 times 3, I'm sorry. There are no books, there's nothing to take out, so that's just going to simplify to radical 6. And radical 6, because it is not a perfect square, is an irrational number. And again, if I punch it into the calculator, I'm going to get, this is a listening check. In the title where it says rational, color in the A's. Color in the A's. And you can see those numbers are not repeated. All right, example 12. What if I took, there is an exception to that rule. If I multiply two rational numbers together, so let's take a look at 2 pi times 4/pi. Those are all supposed to be irrational, right? However, you have to be careful because you can see that those 2 pi's are going to cancel, because when you're multiplying fractions, you multiply the top, so that will give me 2 pi times 4. Multiply the bottom, which is going to give me 1 times pi. And you can see the pi's cancel, leaving 2 times 4, which is 8/1, which is now a rational number. So you got to be careful to make sure that you can't cancel anything before you decide if it's rational or irrational. Right, and again, showing you in the calculator. Remember to put parentheses over the whole thing. All right, example 13. What if I add and subtract rational and irrational numbers? Again, the same thing. You just have to be careful to see that they don't cancel. You can see that I can cancel 2 radical 5 minus 2 radical 5 because that's the same thing. It just leaves 3, which means that that's a rational number. So some of these things you actually have to solve before you decide if it's rational or irrational. And then let's take a look at one final example. What if I said 2 plus pi? So a rational number plus an irrational number. Again, because nothing cancels, it's going to be irrational. So if I add to an irrational number, it's going to be irrational, as long as it doesn't cancel the irrational number. Alright, so then I'm just going to show you the calculator again. This is a listening check. Go ahead and color that in, the 5.14. Okay, so there are a few rules that you have to remember when it comes to rational versus irrational. Okay, 1, math enter enter is going to give you to check that it's a fraction. Okay, and you can see I'm putting in all these irrational numbers to check if they become a fraction in case I mislabeled one, and you can see they're not a fraction. So 3 things that you need to remember. First one is the sum or product of 2 rational numbers is also rational. Very important to remember. Sum or product of 2 rational numbers is also rational. And that's example 9 and 10. Go ahead and write that in. Okay, the next thing to remember is a sum or product of rational and irrational. So when you have rational and irrational numbers, okay, that's going to be irrational. That's example 8. Write that in. And finally, the sum or product of 2 irrational numbers could either be rational or irrational. Okay, so rational or irrational. That's example 7, 11, and 12. Go ahead and write those in. And that's pretty much it. So those are the 3 major things that you need to remember. And then sometimes you need to calculate it to see whether it falls under rational or irrational. But that's what that is. So let's practice.